Welcome back, dear students, to video number 5 for Standard 9, chapter number 5, Quadrilaterals. In the previous video, we studied practice set 5.2. Let us continue. Properties of rectangle, rhombus and square. My dear students, if you see the picture given over here, this shows a parallelogram, a rectangle, rhombus and a square. These four type of quadrilaterals share certain properties. That means certain properties are applicable to all, and there are certain properties which are unique to them, which tells them that this is a parallelogram, or this is a rectangle, this is a rhombus, this is a square. We are going to study about these in detail in this part of the chapter. Rectangle, rhombus and square are all parallelograms. So the properties that opposite sides are equal, opposite angles are equal, and diagonals bisect each other hold good in these type of quadrilaterals also. That means these properties are applicable to a parallelogram, a rectangle, rhombus and square. I'll repeat the properties. Opposite sides are equal, opposite angles are equal, and diagonals bisect each other. Besides these, there are some more properties to these quadrilaterals also. So we will study about some more properties which are unique to these quadrilaterals. The first one is in the case of a rectangle. Diagonals of a rectangle are congruent. Now over here there is a figure given for reference. Quadrilateral ABCD is a rectangle. We have to prove that diagonal AC is congruent to diagonal BD. Let us start. In triangle ABC and triangle DCB, we have the triangle over here, ABC, so this triangle, and triangle DCB, this triangle. Segment AB is congruent to segment DC, opposite sides of a rectangle. Angle ABC is congruent to angle DCB, each measures 90 degrees. And side BC is congruent to side segment CB, common side. Therefore, we have triangle ABC congruent to triangle DCB by SAS test of congruency. And when we have the triangles as congruent, we can say that segment AC is congruent to segment DB, corresponding sides of congruent triangles. And these segments are nothing but diagonals of the quadrilateral. That is diagonal AC congruent to diagonal BD, hence proved. Similarly, there is a property which holds true for a square also, and that says that diagonals of a square are congruent. So just like a rectangle, we are going to prove another theorem now in the case of a square. So we have quadrilateral ABCD as a square, and we have to prove that diagonal AC is congruent to diagonal BD. Again, in triangle ABC and triangle DCB, segment AB congruent to segment DC, sides of a square. Angle ABC is congruent to angle DCB. Both measures measure 90 degrees. Segment BC congruent to segment CB, common side. Therefore, we have triangle ABC congruent to triangle DCB by SAS test of congruence. Therefore, seg AC is congruent to segment DB. By the reason is corresponding sides of congruent triangles. And these segments are nothing but diagonals of the quadrilateral. That is diagonal AC congruent to diagonal BD. Hence proved. The next property is of a rhombus. Diagonals of a rhombus are perpendicular bisectors of each other. So we have quadrilateral EFGH as a rhombus. We have to prove that diagonal EG is perpendicular bisector of diagonal HF, and diagonal HF is perpendicular bisector of diagonal EG. Now the first statement tells us that segment EF is congruent to segment EH, and segment GF is congruent to segment GH. This is given information because these are sides of a rhombus, and we know that all sides of rhombus are equal, but we have taken these pairs for a specific reason. Let's see what the reason is. Every point which is equidistant from end points of a segment is on perpendicular bisector of the segment. We know this. I will repeat. Every point which is equidistant from end points of a segment is on perpendicular bisector of the segment. Now see, these are equal and these are also equal. That means they are equidistant. So this point and this point is equidistant. That is point E and point G. They are equidistant, and we know that when they are equidistant from a segment, that means they lie on perpendicular bisector. So point E and point G are on perpendicular bisector of HF. And we also know that one and only one line passes through two distinct points. Therefore, line EG is the perpendicular bisector of diagonal HF. Therefore, line EG is nothing but diagonal EG. Therefore, diagonal EG is the perpendicular bisector of diagonal HF. Now we have proved the first part. Similarly, we can prove that diagonal HF is the perpendicular bisector of EG. Hence proved. What have we proved? We have proved that diagonals of a rhombus are perpendicular bisectors of each other. Now, there are certain points which we need to remember on the basis of what we have studied and some more new properties. So let's see what they are. The first one is diagonals of a rectangle are congruent. Diagonals of a square are congruent. Diagonals of a square are perpendicular bisectors of each other. Diagonals of a square bisect opposite angles. Diagonals of a rhombus are perpendicular bisectors of each other. Diagonals of a rhombus bisect the pairs of opposite angles. My dear students, this is all for now. We will meet in the next video. Till then, thank you for watching.